All right, assalamu alaikum everyone. Let's begin. Walaikum assalam wa rahmatullah. We are starting our next topic today, which is trigonometry. Okay, now before we do that, can someone quickly confirm if you can see my screen?
Yes, sir.
Yes, sir.
Okay, all right, good. Okay, so what have we done related to trigonometry until now? In our last topic, circular measure, we already discussed some basics of trigonometry that you've done in O-levels basically. So we talked about these three trigonometric functions, sine, cos, and tan, and how they're defined using a right angle triangle. This is something that you've done in O-levels as well. So you need to know, for example, sine theta is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. But these were defined with respect to a right angle triangle, right? That's how these ratios were defined using this right angle triangle. One side was called hypotenuse, the side that was adjacent to the angle that was called the base, and the side that was opposite to the angle that was called perpendicular as well. So that's how these ratios were defined. That's what you need to remember. And then if you don't have a right angle triangle, you need to know that sometimes you can use sine rule and cosine rule as well. Then what we also did in the last session was how you can, in the last topic was that how you have some exact values of some of these common angles, 0, 30, 45, 60, and 90 that you need to use sometimes. You can do this on your calculator, but when one of these angles comes, you need to a lot of times use their exact values like this, okay? And then in the last topic, we've also learned about a new unit for angles, and that is radians. So that's also another thing that we know about now. Angles in radians. Okay, so 30 degrees, for instance, is pi over 6. 360 degrees is 2 pi. 180 degrees is pi. 90 is pi over 2, and so on. So you have another unit that is radians now. Okay, so these are things that we have done already in our last topic. Now we're going to start the new things that you need to know in this topic in A levels. So that's all that you know until now from O levels. Now, the first thing that we want to do is we want to extend these functions sine, cos, tan to bigger angles. Now, what does that mean? Remember, these ratios, these functions were defined earlier for only right angle triangles. That's how you have learned their definitions. Now, in a right angle triangle, if you think about it, the angles can only be acute because if one angle is 90 degrees, the sum of all the angles in the triangle has to be 180. So alpha and beta here, they are always going to be acute, right? So they're always going to be less than 90 degrees. They can never be more than 90. So these definitions of sine, cos, and tan that you learned for alpha and beta that were coming from the right angle triangle, they only seem to work for acute angles in this case. But on your calculator. So you should have your calculator with you right now for this particular class because I'll be asking you to try some things on your calculator to try to understand the logic of a few concepts better. So make sure that you have your calculator with you. Try this on your calculator, for instance. Try sine of 130. This is an obtuse angle. This is not even there in a right angle triangle. But if you try this on your calculator, sine of 130, let me do that. Sine of 130 is giving me a value. This is 0.766. So sine 30 gives us some value. Okay, let's try cos of 320 maybe. Cos of 320. That's actually giving the same result as well. Let me try a different. So let's say cos of 340 and see what that gives me. Cos 340. That gives me 0.9396, or you can say 9397. So cos 340 is also giving me a value. Now sine 130 could not be, 130 angle could not be there in a right angle triangle. So how are we getting a result for this? Sine, by definition, the definition that we've learned earlier, in this definition, the angle theta cannot even be more than 90. So where is 130 coming from? 340 degrees. 340 degrees is not even there in any triangle, let alone a right angle triangle. 340 cannot be there in any kind of triangle. So why are we getting a value for cos of 340? Where is that coming from? If you were to try, for instance, tan of 440 degrees, you'll even get a value for that. So tan of 440, what's that? That's giving me 5.67. Well, what about 440 now? Where does 440 come from? The whole circle is 360 degrees. What sense does this make? 440 degrees. Where is that coming from? Why are we getting a value for tan for 440 as well, when that does not even exist in a whole circle, right? Where is that coming from? That's another question that we have. Okay, you can also try, for instance, sine of negative 20, for instance. Sine of negative 20. Let me try this. Sine of minus 20. That gives me minus 0.342. So we even get the value for sine of negative 20. Sine even exists for negative values. Now, what are negative angles? Where do they come from? Right? So we need to understand all of these. How can we have a result of sine, cos, and tan functions for these angles when they do not even exist in a right angle triangle? Some of these do not even exist in any triangle. So how are these defined and how are we getting these values? That's what we want to understand today. Okay, that how can these ratios, how can these functions have results for these angles? Okay. Yes, Abdullah, you want to say something?
Sir, if we take sine inverse of 130, it gives math
Yeah.
error.
Yeah, because that's something different. This is not sine inverse of 130, this is sine of 130. So sine inverse of 130, sine inverse of basically anyone that's greater than 1 is going to give you a math error. So you can try 1.5, 2, 150. Anything greater than 1, sine inverse does not exist for that. We'll talk about that later as well. But we're not using sine inverse here. We're using sine of 130. It's not sine inverse. Okay. So all of these values, all of these angles are giving us some result when we apply sine, cos, tan on them. Okay. So now we need to understand where all of these angles are coming from. Let's try to understand this now. So first of all, we need to understand how are angles measured in the first place. Let's think of these x and y axes. We have x axis here and we have y axis here. Let me draw some lines. I have this line here. Let's say this line has an angle of 40 degrees with the x axis. I have another line here. And this line has, let's say, this angle 60 degrees with the x axis. And I draw another line here like this. This line, let's say, has an angle of 45 degrees. And another line. This line has an angle of, let's say, 30 degrees here with the x-axis, this last quadrant. Now, what are the angles of these different lines? First of all, we need to know that angles are always measured from the positive x-axis. Okay, angles are always measured from the positive x-axis. Let me write that down here. So angle is always measured angle is always measured from the positive x-axis, and that's where we measure angles from. Okay, so this yellow line, positive side of x-axis. So x-axis has this positive side, this negative side. So we're saying we're starting from the positive x-axis, from the right-hand side. And when we do this from the right-hand side, what also happens is when we go in the anti-clockwise direction, I'm sorry, this is the y-axis, this is the x-axis. Since we're always measuring angles from this, when we go in the anti-clockwise direction here, we say the angle is positive. And when we go in the clockwise direction here, we say the angle is negative. Okay. Now, there's no particular logic to this as such. This is just the convention that we use. This is the convention that we use, that we measure angles from positive x-axis and we measure them in the anti-clockwise direction. There are other conventions out there as well. This is the one that we use in this topic. Okay, for example, in O levels, you've done bearings, if you remember. For bearings, the convention was that we used to measure angles from this vertical line from the north, and we used to measure them in the clockwise direction. That was the convention that we used to use for bearings. Here, what we say is the convention that we're going to use is that we measure angles from positive x-axis just to standardize things, so that whenever we are talking about angles, we know where we're actually measuring them from, so that everybody understands, okay, this is the convention that we use. So the convention is we start from the positive x-axis and we're going to go in the anti-clockwise direction if we want to measure positive angles. Now, first of all, what's the angle of this green line? The angle of the green line, if we go here like this, we say this is 40 degrees. What about the angle of this orange line? Remember, we're going to start from the positive x-axis. So when we start from the positive x-axis, we can go like this. And we can say, okay, this is the angle that we have of this orange line here. Can we calculate this angle? The angle in a straight line is 180. 180 minus 60. This line therefore has an angle of 120. Okay. So that's how we measure angles from the positive x-axis. Now, what about this blue line? For this, we would say, let's start from here and go like this. What's this angle? 180, that's the angle on straight line, plus 45. What is that? That is going to be 225. So this line's angle is therefore 225 degrees. Okay. And then what about this line here? We can go like this and come to this line here. Okay. What about this angle now? 360 is the angle of the whole circle. If we subtract 30 from 360, we get the angle of this line, and that is 330 degrees. So this is how we can write down the angles for all of these lines. Start measuring from the positive x-axis in the anti-clockwise direction. Like this, we would say, this is 40 degrees, this is 120, 225, and 330. Okay. So that makes sense. That's how we are going to measure. That's how we are actually going to be measuring angles. Now, what about angles like these? 440. How can an angle be more than 360? Well, that happens. For instance, if we were to complete one full circle and then start going again. So for example, this angle 40 that we have here, we could also write this angle 40 as 360. We complete one full circle, that gives us 360, and we add 40 to that. So 360 plus 40, we could say this line has an angle of 400 degrees. That's also possible, right? 40 plus 360, that gives us 400. Similarly, this 120, we could say, let's go one full circle and then come back to this line again. So that's 360 plus 120. What's that? That's 480. That could also be the angle of this line. The blue one, how do you find the angle for this? If you were to go more than one full circle, we'd say 360 plus 225, that gives us 585. And then similarly, in the last one, that's 360 plus 330, that gives us 690. So these same lines could be called to have these angles as well. Could be understood to have these angles as well, right? More than 360. And then what about the negative angles? Remember, we said if we are going in the clockwise, in the anti-clockwise direction, we would say the angle is positive. If we are going in the clockwise direction, we would say the angle is negative. So instead of going in the anti-clockwise direction, if we went in the clockwise direction instead, from the positive x-axis, like this, we would say the angle of this line below is minus 30 degrees, like this angle. This is negative 30. That's also possible. Similarly, for the blue line, we could say, we could go like this. What is this angle? The angle in the straight line is 180. 180 minus 45, that gives you 135. But since we're going in the clockwise direction, we could say this is minus 135 degrees. So this blue line could also be said to have an angle of minus 135. And similarly, the rest of them, we could go to this orange line like this. That will be 180 plus 60, right? 180 plus 60, that's 240. But since we're going clockwise, that will be minus 240. And similarly, for the last one, the green one, we could say we could go like this. That's 360 minus 40, 320. So 320. But since we're going clockwise, we say this is negative 320. So for the same lines, we could say, we could have any of these angles. And not just these, you can just keep adding 360 or keep subtracting 360 to get more angles. For example, for this green line, you could add 360 more to get 760, then add 360 more to get 1120. You could subtract 360 from this to get minus 680, and so on. It keeps going on like this. You can keep going in circles. You'll get more and more angles. All of these angles are going to be equivalent. Okay? All of these angles are going to be equivalent to each other. What that means is, if you find, for instance, sine, cos, or tan, any of those ratios for these angles, for example, you can try sine of minus 320, you can try that. You can find sine of 40. You can try sine of 400. Since these are equivalent angles, all of these numbers are going to be the same. Sine of minus 320, sine of 40, sine of 400, all of them are going to give you the same value. You can try that. All of them give you the same value. Okay. So that's the concept, first of all, of these bigger angles. Angles more than 360 and also negative angles. All of these give you what? You can try this. They give you 0.643. All of them give you the same result because all of them are equivalent angles. Okay, so that's the first thing we need to understand. Where do these bigger angles come from, first of all? Because a full circle is just 360. So more than 360 angle comes when you go around more than one full circle, okay? And then if you go in the clockwise direction, the angles are negative like this. Okay. Now, before we go further, we also want to number these 4 different regions that we have here to be able to refer to those regions. So basically this X and Y axis that you have. This is the Y axis, right? This is the X axis. These X and Y axes divide your paper or divide your screen in 4 different regions. So there's one region on top left here, one region on top, one region on top right, one region on top left, one region on bottom left, and then one region on bottom right. What we do is, in order to be able to refer to these regions, we number them. So the region on top right is numbered 1. We say this is quadrant 1, right? Remember quadrant is 1/4 of a circle. So this is quadrant 1. And then we go in the anti-clockwise direction. But remember, because we're measuring angles anti-clockwise like this. So we go anti-clockwise in this numbering. We say this is quadrant number 2. And then this is quadrant number 3. And this is quadrant number 4. So whenever we say quadrant 1, we know what we're talking about. We're talking about the top right region. When we say quadrant 2, we're talking about the top left region. And similarly for quadrant 3 and quadrant 4. You need to be able to refer to these quadrants by these numbers. Quadrant 1, 2, 3, 4. Make sense? Any problem with this? Okay, so that's how we measure angles, first of all. Now, we understood that this is how these bigger angles come, but then what about sine of 130? What about cos of 340? How do we even calculate these ratios now? Because we used to define these ratios using right angle triangles earlier. But now if we have bigger angles, how do we make right angle triangles? That's the next question, okay? Let's try to answer that question now. How do you find sine of an angle that's more than 90? How do we define that? So now what we're going to do is we're going to change our definitions of sine, cos, and tan slightly, okay? So I'm not going to say what you've done before was wrong. It was correct, but it was kind of incomplete, right? In O levels, you basically did not understand how to find sine, cos, tan of bigger angles. That's what we're going to do now. We're going to extend those definitions, okay? We're going to extend those definitions that you did earlier. Now, let's understand how. So let's take this angle, this line in the first quadrant, right? So remember the numbers now, 1, 2, 3, 4, quadrant 1, top right, quadrant 2 on top left, and similarly 3, 4, okay? 1, 2, 3, 4. So we're talking about quadrant 1, first of all. In quadrant 1, since you see the angles are going to be like this, 0 degrees, we start from 0, and then we have 90 degrees here, and then 180 degrees here, 270 here, and then 360 again here. So in quadrant 1, if we start from 0, we have angles from 0 to 90. So that's acute angles. That's where we have been working in O levels, right? Where the angles were acute. So let's say this angle here was 30. And we have a triangle like this. What would be the angle of this line? The angle of this line would be 30 as well, because remember we measure angles from the positive x-axis. So we measure the angle of this line from the positive x-axis. So this line has an angle of 30 degrees. All right. Now, how do you find sine of this angle, for instance? How do you find sine of this angle? Remember the definition of sine that you used to have earlier? Sine was defined as opposite over the hypotenuse, and cos was defined as adjacent over hypotenuse, and tan was defined as opposite over adjacent. What we're going to do now is we're going to change those definitions slightly Instead of saying this side is opposite, since we are working on this xy plane, let's talk about this particular point. This particular point would have coordinates x, y, right? So this point would be y here, and this point would be x. What's the length of this opposite side? This length is going to be y, right? The y coordinate of this point. What about this horizontal length? This horizontal length is going to be x, right? And what about this hypotenuse? The hypotenuse is going to be h still. Instead of writing sine, cos, and tan in terms of opposite and adjacent, what we do instead here is we say, let's write sine, cos, tan. Let's define sine, cos, and tan using the x and y coordinates instead. So we have this triangle. We would say y is the opposite, right? X is adjacent. So now what would be the value for sine here? We would say sine of 30 degrees. That's what we are looking at this point. Sine of 30 degrees. What's that? Sine of 30 is y over h, right? That's what sine of 30 here turns out to be. What about of 30? That will be over h. And then what about tan of 30? Tan of 30 would be y over x, right? So instead of calling them adjacent and opposite, what we're doing is we're calling them x and y, where x represents the x coordinate of this point and y represents the y coordinate of that point. And if we use these definitions, now we can extend the idea of sine, cos, and tan to bigger angles as well. Now, how do we do that? If we go in the second quadrant now, in the second quadrant, if we make a similar triangle that has an angle of 30 degrees with the horizontal here as well, and we make if we make a triangle like this, a right angle triangle, and the second quadrant now, remember this is the second quadrant, so let me actually write down the numbers here. This is the first quadrant, this is the second quadrant, and then you have the third quadrant here, and the fourth quadrant here. These are the four quadrants that we've got. So now we're talking about the second quadrant. In the second quadrant, if this angle was 30, and we will learn later, this angle is actually known as the basic angle. We'll talk about this later. Basic angle, it's a very important angle. What's the angle of this line, by the way? The angle of this line? The angle of this line is this, which is 150, right? That's the angle of this line here. Now, in this case as well, this length is y, right? And since these two triangles are going to be the same because the angle here is the same, so the ratio between x, y, and z, these are similar triangles. So the ratio between x, y, and h is going to be same. In similar triangles, the ratio of the corresponding sides is equal, remember? So if we say this side is y, and this is x, and this is h. Now, what about sine, cos, and tan here? We can say sine of 150 is equal to y over h. Sine of 150 is cos of 150 is equal to x over h, and tan of 150 is equal to y over x. So now the angle that we're talking about is this 150 angle, right? That's the angle of this line that we have in the second quadrant. Remember how we measure angles? This is how we measure angles, 150 degrees. And now this point has coordinates y and x. Since we changed the definition of sine, cos, and tan now to call them y over h, instead of perpendicular, we have y, instead of base, we've got x. We're calling them y over h, x over h, and y over x now. Now we can write down the values of sine of 150 and cos of 150 and tan of 150 as well. Okay, So sine of 150 is also going to be y over h. Cos of 150 is also x over h, just like before here. And tan of 150 is also y over x here. Okay, but there's a slight difference. What's that difference? In the first quadrant, if you think about it, y coordinate is positive and the x coordinate is also going to be positive. H represents the length of this point from the origin. That is always going to be positive. H can never be negative, but x and y, they are sometimes going to be positive, sometimes going to be negative, depending on which quadrant you are in. If you are in the first quadrant, in the first quadrant, both y and x are positive. So all of these are going to be positive. Y is positive, x is positive, right? And h is always positive. So all of these are positive. But in the second quadrant, y is positive, but x coordinate is going to be negative. When you are on the left side, the x coordinate is negative. Now, because of that, what happens is sine has y over h. Y is positive. H is always positive. So sine remains positive. However, since the x coordinate becomes negative on this side, x is negative, h is positive. What that gives us is that cos, the value of cos is going to be negative because x is negative, h is positive, one negative value that makes the whole thing negative. Similarly, what about tan? In tan, we have y positive, but x is negative. Tan is also going to be negative. So if you try this now, try finding sine of 30 on your calculator. Sine 30 gives you 1 over 2. And sine of 150 also gives you 1 over 2. They give you the same value. The same value is because of the same basic angle, which is 30. The value is the same. They're both positive as well. However, if you were to do this for cos of 30 is under root 3 over 2. Cos of 150 is also under root 3 over 2, but there's this negative sign with that as well. And similarly for tan as well, you can try tan of 30 and tan of 150 as well. In the first quadrant, the values will be positive. In the second quadrant, cos and tan are going to be negative. Okay. So number one, how do we extend sine, cos, and tan to bigger angles now? We have changed the definition slightly. We're saying instead of opposite, we have y coordinate. Instead of adjacent, we have the x coordinate, right? So x and y coordinates now exist in the second quadrant as well, in the third quadrant as well, in the fourth quadrant as well. So even for bigger angles now, even for angle 150, we can say that sine, cos, and tan are defined because we have the y coordinate of this point, we have the x coordinate of this point, and we can just use that ratio like this. Okay, now let's extend this to the next quadrant as well. So in the third quadrant, for instance. Now, all of this is important because we are going to basically combine all of this by the end of this class and use all of these concepts to solve equations. Okay, so these are all building blocks that we're doing right now. So make sure that you're focusing and it'll all make sense by the end. Okay, so in the third quadrant now, we have this angle 30 here as well. What about the angle of this line? It's going to be 180 plus 30. So this line has an angle of 210. This line has an angle of 210. Now, if we were to find sine, cos, and tan in this quadrant, let's see what they are going to be. Sine of 210, cos of 210, and tan of 210. What about sine? How is sine defined? Sine is defined as y over h, cos is defined as x over h, tan is defined as y over x. Now, in the third quadrant that we have here, x is negative, and if you think about it, y is also going to be negative. X and y both are negative. So that means Sine is negative because of the y being negative. Cos is negative because of the x being negative. However, tan is positive because both x and y are negative. So negative and negative, they get cancelled out and you have a positive result. So in the third quadrant, we understand that the values of sine and cos are going to be negative and the value of tan is going to be positive. Okay. Similarly, we could extend it to the fourth quadrant as well. And let's say if we had this triangle like this in the fourth quadrant as well, with the angle here being 30, what would be the angle of this line? This line would have an angle of 330 degrees, right? 360 minus 30, that's 330 degrees. And similarly here, we could make a right angle triangle here. And here x is positive, however, y is negative. And you could write down sine of 330 and cos of 330 and tan of 330 here. Sine is defined as y over h, cos is defined as x over h, tan is defined as y over x. Now here you see y is negative, h is positive, so sine becomes negative. X is positive, cos is positive, y is negative, and x is positive, so tan is also negative. What we understand from this is, number one, we can extend these functions to the other quadrants. How? By changing the definition of sine, cos, and tan now. Instead of adjacent, we would be saying x coordinate. Instead of opposite, we would be saying the y coordinate. Now, since x and y coordinates exist in all of these quadrants, we say these are the definitions in each quadrant now. In fact, the definition remains the same. However, the sign of x and y coordinates change in each quadrant. And if you were to summarize all of this, what you get from this is that in the first quadrant, you can write that here, number 1, number 2, number 3, number 4. You get an important result from all of this exercise. And that is in the first quadrant, that means whenever the angle is acute from 0 to 90 degrees, in the first quadrant, all ratios, that means all of sine, cos, and tan, all of them are positive. In the first quadrant, all of them are positive. Sine, cos, and tan all have positive results. In the second quadrant, you see cos becomes negative, tan becomes negative, only sine is positive. So what you can remember in the second quadrant is you can say sine is positive, the other two are negative. Okay, so if you just write sine positive, that means the others are negative. Okay, then in the third quadrant, you see tan is positive and sine and cos both are negative. So you can say in the third quadrant, you've got tan that is positive. If tan is positive, you say the other two, which are sine and cos, they are negative. And in the fourth quadrant, is positive and sine and tan are negative. So this is a very important result that you will be using to solve trigonometric equations, that which ratios or which functions are positive in each quadrant. So in the first quadrant, we are saying all functions are positive. Sine, cos, tan, all are positive. In the second quadrant, we are saying only sine is positive. In the third quadrant, we are saying only tan is positive, the other two are negative. And in the fourth quadrant, we are saying only cos is positive and the other two are negative. This is something that you need to remember now. You can remember the initials like this, A, S, T, C. Okay, and there are also different acronyms that you have for this. You can kind of remember one of those as well. So one very common one that's used here is add sugar to coffee. You can remember the first letters of these words, A, S, P, C. So all that means is in the first quadrant, all ratios are positive. In the second quadrant, sine is positive. In the third quadrant, tan is positive. In the fourth quadrant, cos is positive. You need to remember this now, that in each quadrant, which function is positive. Okay, so this is an important result that we get from this. In the first quadrant, all ratios are positive. In the second, sine is positive. In this third, tan is positive. And the fourth, cos is positive. ASTC, add sugar to coffee. That's a way to remember this. This is what you need to remember. Okay, that for each quadrant, which ratios are positive and which ratios are negative. That's one thing. That's one result that we get from this exercise that we just did. Okay, but there's another very important result, and that is about something that we call basic angle. The basic angle. Now, you see these triangles that I made there, all of them had this angle here equal to 30. So there was a reason why I made all of them to have the same angle. Now, there's nothing special about 30 here. It could be any angle as long as it was the same at all of those quadrants. So the angle 30 was basically the same in all quadrants. Okay. This angle that a line makes with the horizontal x-axis, horizontal line, this is known as basic angle. And we will be referring to this again and again. Basic angle, we often refer to this with this letter alpha. It's the angle made with horizontal line or with the horizontal axis. Okay. So for example, the green line makes 30 degrees here. The orange line makes 30. The blue line makes 30. The whatever this color is, this purple also makes 30 here. So all of these lines are making 30 degrees with the horizontal axis. So we basically say the basic angle for all of these angles that we had here, 30, 150, 210, and 330 is the same. Now that is important. Why is that important? Because if you were to find sine, cos, or tan of all of these 30, 150, 210, 330, you would find something interesting there. Let's do that exercise. Because again, that's going to be important to understand the concept behind it. Let's try this. Sine of 30 degrees, sine of 150 degrees. Let me just write everything down here. First of all, sine of 210 degrees and sine of 330 degrees. Do the same thing for a cos. Cos of 30 degrees, cos of 150 degrees, cos of 210 degrees, cos of 330 degrees. And then you have tan of 30 degrees, tan of 150 degrees, tan of 210 degrees, and tan of 330 degrees. Let's calculate all of these on our calculator. Sine 30. So try this on your calculator. That gives you 1/2. Try cos 30. In fact, let's stick to sine for now. Sine 30, try that on your calculator. That gives you 1/2. And if you would try the rest of them, sine of 150, sine of 210, sine of 330, you would realize all of them actually give you the same result. All of them give you the same result. Sine of 150 is also 1/2. Sine of 210 is also 1/2. Sine of 330 is also 1/2. All of them have the same magnitude. The only difference is sine 30 and sine 150 are positive. Sine 210 and sine 330, they are negative. Okay. The magnitudes for all of them are the same. They're all 1 over 2. They're all 1 over 2. Try this for cos as well. Cos of 30. Try that. That's under root 3 over 2. 150 is also under root 3 over 2. 210 is also under root 3 over 2. 330 is also under root 3 over 2. All of them are under root 3 over 2. The only difference is some of them are positive, some of them are negative. Now, since cos is positive in the first quadrant, the first one is positive. Cos is negative in the second quadrant. This is negative. Cos is negative in the third quadrant as well. This is also negative. Cos is positive in the fourth quadrant. This is going to be positive. But the magnitudes for all of them are the same. And what about tan? Let's try this for tan as well. Tan 30, if you try that, that will give you under root 3 over 3, I think. Then under tan of 150 is also going to be the same. Tan of 210 is going to be the same as well. And then tan of 330 is also going to be under root 3 over 3. So all of them give you the same result in terms of magnitude, but then the only difference is the positive and negative signs. Tan is positive in the first quadrant and in the third quadrant, so they are positive. And the second and fourth are negative. Now, why are we getting the same number in terms of magnitude? The reason for that is that the basic angle for all of them is 90 degrees. And the magnitude of this ratio is decided by that basic angle. Why? Because if the basic angle is the same, the triangles that you get from that angle, they're all going to be similar. If the basic angle is same, you have all similar triangles. And since the triangles are similar, the ratios are going to be the same, right? Similar triangles have the same ratios. So if the basic angle is same, the magnitude of sine turns out to be the same for all of these angles. Magnitude of cos turns out to be the same for all of these angles. And magnitudes of tan turn out to be the same for all of these angles as well. So what we understand from this is, if the basic angle, or you can say the magnitudes of sine let me think about how to write it down first. Actually, yeah. If the basic angle for a set of angles is the same, what that means is the sine or the magnitude of sine for all those angles is going to be the same. And not just that, the magnitude of cos of all of those angles is also the same. The magnitude of tan of all these angles is also the same. So you can just add that here. This is an important result. If the basic angle is the same, that means the sines of all of those angles are the same. The cos of all of those angles are the same. The tan of all of those angles is the same as well. the magnitude is going to be the same. The only difference is going to be positive or negative sign. And how is that decided? The positive and negative signs are decided by which quadrant that angle is in. If it's the first quadrant, all are positive. If it's the second quadrant, sine is positive, cos and tan are negative. If it's the third quadrant, only tan is positive. If it's the fourth quadrant, only cos is positive. So when you're figuring out whether what result an angle is going to give, when you take sine of that or cos of that or tan of that, there are two things that are important. One is the basic angle, and the second thing, which quadrant it's in. When you know these two things, what the basic angle is and what the quadrant is, you can figure out what the result is going to be. Okay, so that's important now. Basic angle is the angle made with the horizontal axis. Basic angle is the angle made with the horizontal axis. If the basic angle is the same, the magnitudes of these ratios is going to be the same. And quadrants decide whether quadrants decide which function is going to be positive, which function is going to be negative, based on where it falls. Okay. Now, all of this background was basically important to be able to solve equations. Solve equations that look like this, for instance. So now this is the culmination of all of that background that we discussed. We want to be able to solve equations that look like this. If we have an equation like this, sine theta equal to minus 0.5, for instance, we want to solve this equation, right? We want to solve this equation. How can we solve this equation? For this, we're going to use all of this that we have learned here now, okay? So all of that was to be able to solve equations that equals minus 0.5. Now, the way you used to do the O-levels was, you would say, just take sine inverse, right? Take sine inverse, and that gives you sine inverse of 0.5. In fact, minus 0.5, that's how you would do it in O-levels, right? Take sine inverse of negative 0.5. What does that give you? Sine inverse of minus 0.5. That gives you minus 30. And you would say, this is the result, right? That's what you would do in O-levels, right? And that's correct in the sense that minus 30 is one possible solution of this equation, and that's fine. This is one possible solution, yes. However, there are many other possible solutions as well, which you can miss out on if you just do this, because your calculator can only give you a single result. So if I do this on my calculator, I just did sine inverse of minus 0.5, and that gave me minus 30 as the result. That was the only answer that my calculator gave. But try this. If theta was equal to, for instance, 210, put 210 here, sine 210, calculate what that is. That is also minus 0.5. So that should also have been a solution. Your calculator does not give you that. Try 330 degrees. This is also a solution of this equation, but your calculator does not give you that. You could try theta equals minus 150. That is also a possible solution of this equation. You can try that here. You can input that here. That the result turns out to be minus 0.5. It satisfies the equation. And in fact, there are infinitely many possible solutions for this. There are many possible answers for this, right? You can just keep adding 360 or subtracting 360 to these values. You will get so many other answers. Your calculator, however, can only give you one answer. So how do you find the rest of these answers? To find all the rest of those answers, you will need to use these things that we have just learned. Two things that are important: basic angle and quadrants. Okay, basic angle and quadrants. We're going to use those concepts now to understand how to solve equations like these. So we can't do sine inverse directly like this. We understood why, because that will only give us one value. We would miss out on so many other possible values that we could have from that equation. So how do we solve equations like these? Then let's go through this process. Let's understand this process. Now, since equations like these can have infinitely many possible answers, whenever you have to solve such an equation, they would almost always give you some kind of an interval. So for example, in this question, they might give you that theta is supposed to be between 0 degrees and 360 degrees. All right, that might be given in the question. Okay. And now what that means is you're only looking for those values of theta that fall within this interval. Because if there was no interval given, then it was not possible to write down all possible answers, because there are infinitely many possible answers. You can't possibly write all of them. So they give you a range like this. So in this case, if they say theta is supposed to be between 0 and 360, how do we solve such an equation? This is the process that we're going to follow. Okay, remember the two things that were important? The two things that were important were what the basic angle is and which quadrants you're talking about. Okay, basic angle and quadrants. Basic angle and quadrants. What was the basic angle? Basic angle was the angle made with the horizontal axis. Let me actually be a bit more specific here, because not just any angle. This angle will always be an acute angle. It's the acute angle made with the horizontal axis, right? So this angle theta, angle 30 is acute here. It's the acute angle made with the horizontal axis. Okay, so the basic angle here for all of these was equal to 30 degrees. The basic angle for 30, 150, 210, 330, all of these have the same basic angle, which is 30 degrees. Okay, so basic angle is acute angle made with the horizontal axis. Those are the two things that we're going to use for this. Now, first of all, sine here is negative. The result of sine is negative. That means is, which quadrants can we be in? Sine negative, remember? A, S, C. Sine is positive in the first quadrant and in the second quadrant. In the first quadrant, all are positive. In the second quadrant, sine is positive. Here, sine is supposed to be negative. So where can we be? We can only be in the third quadrant or in the fourth quadrant. These are the only possible quadrants that we have. So we can only be in one of these quadrants. So one thing that you decide is which quadrant you're going to be in. So we can either be in the third quadrant or in the fourth quadrant. So quadrants decided. Now the only thing that we need is the basic angle. So if we can find out the basic angle, for example, if we knew the basic angle is 20, let's say, we could figure out how to get to that 20, right? Because angle is supposed to be measured from the positive x-axis, we can figure out what the angle turns out to be then. Now the next problem is how to find the basic angle. That's the only problem that's left now. Once we have the basic angle figured out, we can write down. How do you find the basic angle now? This is the process that we use to find the basic angle. What you're going to do is you're going to replace theta with alpha. So I'm going to write it down here. The first step you have to do is find the basic angle. That's the first thing that you have to do. After figuring out which quadrant you fall in, so yeah, find the basic angle. How do you do that? You're going to replace theta with alpha and make the right side positive. That's what you have to do to find the basic angle. Make the right side positive. Find the basic angle. How do you do that? Two things. Replace theta with alpha, and number two, make the right side positive. Okay, how does that happen? Let me write that here. Sine theta was equal to minus 0.5. All you have to do is write this as sine alpha equal to, make this positive. If it's already positive, you leave it as positive. If it's negative, you have to make it positive. So it becomes sine alpha equals 0.5. Okay, so it's sine alpha equals 0.5. Now, the basic angle. Now you do sine inverse of 0.5. Now, why are we doing this? Why are we making it positive? Because remember, we said alpha, the basic angle, is supposed to be an acute angle. Where does an acute angle fall? Acute angle is in the first quadrant, right? Generally, right? It's the first quadrant. Acute angle 0 to 90, that's an acute angle. In the first quadrant, all ratios are positive. So the general rule that we use is whenever we have to find the basic angle, we just make this thing positive, and our calculator will give us an acute angle as a result for that. Okay. Otherwise, if you use negative here, sometimes the calculator is not going to give us an acute angle. So we always make it positive. Okay. We always make it positive. Make the right side positive. So this is what you get. And then do alpha equals sine inverse of 0.5. The value of alpha turns out to be what? Sine inverse of 0.5. I think that's 30. You can try that. Sine inverse of 0.5 is 30. What that means is the basic angle is 30. Okay, the basic angle is 30. That means we could either be here, either this angle is 30, or this angle here is 30. Okay, and now we measure angle from the positive x-axis. Abdullah, just give me a minute. Now we measure angle from the positive x-axis, keeping in mind the interval that we have. The interval is from 0 to 360. So we have to go in the anti-clockwise direction. So we say, okay, let's go in the anti-clockwise direction. This is the first angle that we get. What's this? We say theta is either equal to 180 plus 30 degrees. That's one possible value for theta in our interval, 210. And then theta is either equal, or theta is equal to this angle, which is going to be 360 minus 30 degrees, and that is 330 degrees. These are the two possible answers for theta that we get within this interval that we were given from 0 to 360. These are the two values of theta that satisfy this equation. So how do we solve these equations then? Find the basic angle. How do you do that? Replace theta with alpha. Make the right side positive. Just do sine inverse, and that gives you basic angle. Once you have the basic angle, look at the quadrants. Think about which quadrants you can be in. Since sine is supposed to be negative, you can either be in the third quadrant or in the fourth quadrant. Just draw those basic angles in the third quadrant and the fourth quadrant, and you can figure out, okay, 210 and 330, these are the possible angles that you have. These are the two solutions for this equation. Make sense? Yes, Abdullah.
Sir, before even before even replacing theta with alpha, the value was minus 0.5. So
Yeah.
then, so we said that the quadrants are third and fourth. But after making it positive, shouldn't the quadrants be first and second, as all values of quadrant trigonometric ratios are positive in first quadrant, and in second the sign is positive. So you chose third and fourth. Why?
Remember, we are finding theta. We're not finding alpha. We are solving this equation. This is the equation that we are solving. We are looking for the value of theta. That's the final result that we want. Sine of theta is minus 0.5. Okay, sine of theta is minus 0.5. We look at that sign to figure out which quadrants we are going to be in. This we are making positive ourselves, and we're doing that just to find the basic angle. The original number is still negative. We make it positive just to find the basic angle, and that is the reason why we replace theta with alpha, because we are not saying that sine theta equals 0.5. That's not what we're saying. We're not equating sine theta to plus 0.5. This is still minus 0.5. We are introducing another letter there just to not have that confusion, that now sine alpha equals 0.5. So this is the value that we're getting for alpha. Alpha, yes, you could say, now going to be in the first quadrant because it's positive. However, eventually, what we need is the value of theta. And that's going to be in the third and fourth quadrants, because sine of theta was negative. Otherwise, if you were to consider this sign would always be positive then, because you will always make it positive yourself. So first quadrant is always going to be there. That does not make sense. The sign that you're going to consider for quadrants is going to be this original sign, okay? Not the sign after making the change, because this change is being made by you, okay? And that's only for calculating the basic angle. So that's not what you're going to look at for assigning the quadrants. Quadrants are going to be assigned using this original positive or negative sign that's there, okay? Not after you make it positive yourself. So for deciding quadrants, you look at the original sign. You need to remember, okay? Not after you make it positive. You have to look at the original sign that's there in the question. Make sense?
Okay, sir. Thank you.
Okay, now before we end, or I think we could end here. We understood the logic for this, or maybe just one more example, then we end. Quick one. If we had to solve, for instance, this cos theta equals 0.2, and theta was now between minus 180 and plus 180. If we had to solve this equation, how would we do this? Again, use that same process as before. Is cos positive or negative here? Cos is positive. So which quadrants is it going to be in? Cos is positive in the first quadrant and the fourth quadrant, ASTC, right? It's either the first quadrant or the fourth quadrant. What do we do now? Let's find the basic angle. Cos alpha, replace theta with alpha. Make the right side positive. In this case, it's already positive, so you keep it positive. Find the basic angle. Cos inverse of 0.2. Cos inverse of 0.2 gives me 78.46. That's the value of the basic angle that we get from this. Okay. Now, which quadrant can we be in? We can be in the first quadrant. So the angle could either be here, that's 78.46 degrees, or we could be in the fourth quadrant like this. So the angle here could also be 78.46 degrees. Now we have to look at the interval that's given. Interval is from minus 180 to plus 180. Okay. Now, first of all, let's go in the anti-clockwise direction like this. This is the first angle that we find. Is that in the interval? It is. Theta equals 78.46. That's the first angle that we get. Okay. Now, let's go further and get to this angle. What is this going to be? It's going to be 360 minus 78.46. And that's going to be 280 something, 281 maybe. No, 200 and, what is this going to be? 281, right? 281 point something. But that's not in our interval. That's outside our interval. So we can't do this. We can't go beyond 1.
281.54.
Yeah, 281.54. So we can't go beyond 180. So we say this is not our possible. This is not a possible answer, because as this is a possible answer, but this is outside the interval. So we don't consider this. Okay. So in the positive direction, we say we can't find any other answer then. This is the only answer that we've got. However, if we look at the interval that's given, you also have negative values in the interval. That means you might also have to go in the negative direction. That is in the clockwise direction. So you should also figure out if there are any angles in the negative direction now, which fall in the interval. So let's go clockwise. This is the first angle that we find, and that is theta equals minus 78.46. That is also in the interval. So that's another possible answer. Then in the negative direction, you could go further and get to this, but that's going to be outside the interval. That's going to be below minus 180. So that's not a possible answer. These are two answers that we get: 78.46 and minus 78.46. This is the solution of this equation. Make sense? That's how we solve trigonometric equations. Now I'm going to write down some examples here. You can try them for tomorrow. And then tomorrow we will discuss those examples and discuss trigonometric identities and do some practice questions after that. Okay. So let me write down some examples here, which I want you to try before tomorrow, because we will be discussing these in class. So it's going to help if you have done these already in your own time. So if you have tan theta equals under root 3, and the interval is, let's say, from minus 180 to 540. Let me write down another equation here. Let's say you have sine of x equals under root 3 over 2, and x is now between, let's say, minus 2 pi to pi. We have radians now, so we could have radians as well. Okay. Now this does not have a degree sign. That means it's radians. Okay. Let me write down another equation. Let's say you have something like this: sine of theta equal to 0, and the interval is from 0 degrees to 30 degrees, or in fact 360 degrees. It's theta here. And then you could have another example like this: sine of theta equals -1. And again, if theta is from, let's say, minus 360 to plus 360, and then you could try this as well. Cos of theta equals -2, and theta is between whatever, doesn't matter here, but it's a 0 degrees and 360 degrees. Okay, try these examples. Just 5 of these should not take you more than, I think, 20 minutes. So try this, and we will discuss these tomorrow. Okay, you can take a snapshot if you want. Maybe share that in the group as well, so everybody can try before tomorrow. And then we'll discuss these examples and do identities as well. Okay, that's for tomorrow. If you have any quick questions, let me know. Otherwise, that's it for today. Inshallah, from tomorrow, we're going to bring our time back again. It's getting a bit too late for the last couple of days. So we will try to start on time from next class again. So it's my fault. I've been starting my first class a bit late, and then it keeps getting more and more delayed, the next classes. So we will try to get back to our original time from tomorrow, inshallah, hopefully. Okay, so any quick questions?
No, sir.
No?
Sir,
All right,
will
I'll see
we
you again
have class
tomorrow. Yeah.
tomorrow? Will we have
Hopefully,
class
yes.
tomorrow?
Yeah, so I plan to have a class tomorrow. But in case there's some internet disruption or I get stuck somewhere after voting, then yeah, maybe we could reschedule it. But as of now, yes, we are having a class tomorrow, inshallah. Okay.
Allah
All
Hafiz,
right.
sir.
Allah Hafiz.